R.5 nonlinear functions and modules. Linear functions, as we did in the previous section, are written in the form y equals mx plus p. Those are linear functions. Nonlinear, anything else is nonlinear. It could be quadratic, cubics, anything. We focus on the quadratic for now. Quadratics are written in the form y equals ax squared plus bx plus c. A cannot be 0. A cannot be 0. If A positive, it opens up. If A negative, it opens down. It's a parabola, right? Do you guys remember?
Yes.
This is a parabola. So as soon as you look at the equation, you will find out if it opens upward or downward without before you start graphing. So now what we need to do is to find out how do we graph quadratics by hand. How do we graph quadratics by hand? To do graphing, we find what we call the vertex, this point, the highest points or the lowest point. We use the formula x equals negative b over what?
2a.
2a to find the x value, and then substitute to find the y value. So let's say we would like to graph y equals x squared plus 2x minus 3. How do we graph this one? Well, this is 1 here. A is 1, B is 2, and C is negative 3. We use x equals negative b over 2a. So negative 2 over 2 times 1. That's a negative 1. That's the x. Now the y, we just substitute that into the original equation. Negative 1 squared for x plus 2 times negative 1 minus 3. So y would be 1 minus 2 minus 3, negative 4. So the vertex has coordinates negative 1, negative 4. Now to finish that up, we construct a table of values. You put x equals negative 4, negative 1, negative 4 in the middle, like so, of the table. And we pick or choose two values that are larger than negative 1 and two values smaller than negative 1. So on the number line after negative 1 here you get 0, and then after that is 1. Before that would be negative 2 and negative 3. And then what do we do next? Well, this is what we do. It's easier to take x equals 0. If you substitute x equals 0, what do you get for y? So again, y equals x squared plus 2x minus 3. If you substitute the 0 in, 0 plus 0 minus 3. So it's negative 3. By symmetry, if this is negative 3, this should be negative 3 as well. Now substitute the 1. in here for x, 1 squared plus 2 times 1 minus 3. That would be 1 plus 2 minus 3. 3 minus 3 is 0. If that's a 0, this is also 0. From this one, if we would like to find the intercepts, to find first the x-intercept, or let's find y-intercept. We set x 0, which we already did actually, and we found that y is -3. So this 0, -3 is the y-intercept. To find the y-intercept, you always set the other one, like x 0. If I want to find the x-intercept, we set y 0. Y 0 means the given equation x squared plus 2x minus 3 equals to 0. Then what we do here, we try to factor that out. Luckily enough, this is factorable, xx at 3 and 1, by what we call guess and check or trial and error. It should work out this way, x plus 3 and x minus 1. If you have other ways to factor it, you can do so, it's fine. Then in order for this equation to be 0, this factor is 0 or this factor is 0. Subtract 3 on both sides or add 1 on both sides. So the x-intercepts are -3, 0 and 1, 0. Not all the times when you set y equals 0, you will be able to factor out. Now, if I can't factor out, what should I do? How do I solve equation like this? Well, to solve the quadratic equation, ax squared plus bx plus c equals to 0, we use what we call quadratic formula. The quadratic formula says x equals -b plus or minus the square root of b squared minus 4ac over 2a. So this is called quadratic formula. If in case the quantity under the radical is less than 0, then the equation has no real solutions. The word solutions can be set as zeros or roots. They all mean the same. So if we are asked to solve (3x squared plus 2x equals 7), what do we have to do for this? Well, we first have to make sure every time you have quadratic, set everything equal to 0. So subtract 7 on both sides. And of course, you can try to factor it out. It's not probably going to work out. So A here is 3, B is 2, and C is negative 7. You can use the quadratic formula. X equals negative B plus or minus the square root of B squared minus 4AC over 2A. X equals negative 2 plus or minus 2 squared minus 4. A is 3. C is negative 7. 2 times 3. So now to simplify this, x equals negative 2 plus or minus 4 plus. So 4 times 3, 12. What's 12 times 7? 14. First, like when you multiply it out. So 12 times 7, 8 divided by 6. So x would be negative 2 plus or minus the square root of 88 over 6. X equals negative 2 plus or minus. See, it's not done yet because 88 is divisible by 4, like 4 times 22. And 22, you can only do 2 times 11. You can take it out. But I can take the 4 outside as a 2 and keep the 22 inside over 6. Then what we're going to do is factor 2 on the top. That will give negative 1 plus or minus the square root of 22 over 6. By 2, 1, by 2, 3. So the answer is negative 1 plus or minus the square root of 22 over 3. Let's look at more graphing, slightly different than the one we started with. Y equals negative 2x squared minus 10x minus 5. Try graphing this one as we did for the other example. So to graph this one, we start, you can list them out. Negative 2 for A, B is negative 10, and C is negative 5. So x equals negative B over 2A, negative 10 over 2 times negative 2. That's 10 over negative 4, or negative 5 halves. That's not a pleasant number here. It's negative 2.5. Then we can substitute them back in. X is negative 5 halves square, negative 5 halves minus 5. This is 25 over 4 by 2, 1 by 2, 5 plus 25 minus 5. You can reduce here negative 25 over 2, and this is 20. So that's negative 12 and a half plus 20. That would be 7.5. So the vertex has coordinates negative 2.5 and 7.5. Now we need to construct the table of values. that value goes in the middle, like so. Right above this is -2, then -1, -3, -4. So then we can substitute the -2 in. So again, we can write it again, -2x squared minus 10x minus 5. Just double checking. When x is -2, y would be -2 times -2 squared, -8 plus 20 minus 5, 7. If this is 7, this is 7. X equals -1, -2 times -1 squared. That's a -2 plus 10 minus 5. 3. If that's a 3, this is 3. If you follow the procedure, like how you pick the points, it makes it easier for you. So we found the points, more than enough points to graph it. One more thing though, if we go back to this one, we did find the points, but we didn't graph it. So if you plot the points -1, -4 here, 0, -3, 1, 0, -2, -3, -3, 0. That was the graph of that function. We found everything, but then we get busy finding intercepts, so we forgot to graph it. All you have to do, plot the points and then just connect them. So we can graph this one now. -4, 3. -3, 7. -2.5, 7.5. -2, 7. -1, 3. Any questions about this? Now I want to, if they give you any other function, say they ask you to graph, a random function y equals 1/2 x squared. All you have to do, you can always work on the table of values. Usually we need 5 points. So I would take 0 and stay within the neighborhood of 0. Maybe like pick 1 and 2. And then -1, -2. And then we find the corresponding y values. So when x is 0, y is 0. When x is 1, 1/2. When x is 2, you get 1/2, 2 square. 1/2, 4. That's a 2. If you plug in -1/2, so 1 times -1/2 square is 1/2. If you plug in -2, so 1/2 -2 square, that's a 4. Again, that's a 2. Try to graph this one. And then after you finish plotting that on the graph, try to graph the absolute value function. This is the absolute value of x. 0, 0, 1.5, 2, 2, -1.5, -2, 2. That's this one. For the opposite value, zero, 1, 2. Opposite value of -1 is 1. Opposite value of -2 is 2. Zero, 0, 1, 1, 2, 2, -1, 1, -2, 2. So it goes like a V shape. For this one, I'd like you to try to find the domain and range for this graph. Find domain and range. Then we're gonna graph y equals x minus 2, absolute value. Number 2, y equals the square root of x. We now can move on. Domain for this. Domain is all real numbers and range from 0 to infinity. For the next one, this one here, take x, y values, 0, 1, 2, -1, -2. Usually, how do I know what points I pick for x? If you like to see in the absolute value and a lot of other functions, what you can do, you can set this equal to 0. So you get x equals 2. That number 2 should go in the middle of the table. It makes things easier for you. So 2 goes in the middle. Then you have a 3 and a 4, and a 1 and a 0. If you substitute 2 in, 2 minus 2, 0. If you substitute 3 in, 3 minus 2, 1. 4 minus 2, 2. 1 minus 2 is -1, so that's a 1. 0 minus 2 is -2, that's a 2. And then I'll graph it. 0, 2, 1, 1, 2, 0, 3, 1, 4, 2. So it's a V shape again. Same domain and range as the other one. All real numbers for domain and range 0 to infinity. For the other function, if you set this equal to 0, you get x equals 0 in the middle, then 1 and 2. Now, can I take negative values? The answer is no, you can't pick negative values. If you put -1, it's not going to give you anything. So if 0, the square root of 0 is 0, square root of 1 is 1, square root of 2. 0, 0, 1, 1, 2 square root of 2. Note, back to quadratics, ax squared plus bx plus c, x equals negative b over 2a is called axis of symmetry for the parabola. We may come across other functions, other kinds of functions. For example, let's say we're asked to graph something called rational functions, say 2 over x squared. Well, how do we graph such functions? Well, let's say I'm going to pick values for x and get corresponding y values. If you pick 0, 2 over 0 is undefined. You can't have that. And I'll show you what that means on the graph. If you pick 1, 2 over 1 squared, that's a 2. If you pick 2, 2 over 4 is 1/2. If you pick -1, you will get 2 again. -2, you get 1/2. Let's see if that's enough to graph it or not. So the first thing where it says undefined, that line, x equals 0, this is the y-axis. This is called vertical asymptote. Means the graph is gonna approach it, but it will never cross it or touch it. It's called vertical asymptote. So that line, or that x equals 0, is not in the domain. Now what about if we plot the other points, 1, 2 here, 2, 1/2. Well, is that enough? Well, how about if you take 3? If you want to pick up more points, you get 2 over 9. So it's getting closer. And if you pick up 4, it's getting even closer down to the x-axis. So it's going to come this way. So that's the right-hand side after the 0. To the left of 0, it's -1, 2, -2, 1/2. It seems it's going to go the same way. Like that. So domain is all real numbers except 0. So domain is all real numbers except 0. How about if we are asked to graph something else, also rational function, say x plus 3, x squared plus 8x plus 15. So what do we do here? This looks really difficult to handle. But before you actually start plugging values in or do anything, try to factor the numerator if possible. Okay, how do we factor the numerator? So keep the denominator the same. We can do guess and check like that. Denominator stays the same. So two numbers there, product 15. It could be 15 by 1 or 3 times 5. So x plus 3 and 5. Let me test it. Does that work? Is 3 and 5 their sum 8? Yes. So notice right away these cancel out. So you will get y equals x plus 5. So now we're going to graph y equals x plus 5. That's what we're going to graph. Y equals x plus 5. And then we'll see what we can do about this. X plus 5. How are we going to graph it? That's a straight line. So we're going to graph it as an actual straight line as we did in previous sections. So you can, one way to graph it is pick up values for x, or you can use the slope intercept. So the intercept is 5, 1, 2, 3, 4, 5. Rise 1 and 1 over. So that's the straight line. But we have to watch carefully here. So why they give us this rational function if they could just simply give us x plus 5? Why they have to give us this rational function? Well, what happened here, originally, for the domain of this, the denominator or whatever I just canceled, that cannot be 0, right? Whatever we have in the denominator cannot be 0. So if you subtract 3 on both sides, x cannot be negative 3. X cannot be negative 3. So 1, 2, 3, 4, 5. That's a negative 5 here. That's a 5. X cannot be negative 3. So at negative 3, if you project it up, at that point, there's a hole. There's a hole at that point. That's the idea. There's a hole at that point. Any questions about this? Now, the domain for this domain is all real numbers, all reals except negative 3. You can try to graph a similar one, say x minus 1, x squared, plus 2x minus 3. Okay, we can move on and graph this function. We can factor the top as x minus 1, x plus 3 over x minus 1. These cancel. Keep in mind that denominator cannot be 0, so x cannot be 1. So now I just have to graph the straight line y equals x plus 3. The y-intercept, slope is rise over run. So x cannot be 1. This is 1. So at that point, there's an open circle. Everyone got that? So the domain for this one, all reals except 1.